All right, 4.1 is prime factorization. Okay, now, first of all, we need to review what prime numbers are. Okay, prime numbers are those numbers that have only two factors. Okay? The two factors are the number 1 and itself. Okay, now, so the first few prime numbers, it's 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, and so on. Now, what that means is this. That means 2 has two factors, 2 times 1. 3 has two factors, 3 times 1. 5 has two factors, 5 times 1. 7, 7 times 1. 11, 11 times 1. 13, 13 times 1, so on and so forth. That's why they're prime. Okay, there is only one even prime number, and that's 2. Okay, that's the only even number that's prime is 2. Okay, so 2 is the only even prime number. Now, why wouldn't there be any other even numbers that are prime? Right. Because 2 goes into every single even number, then that automatically makes every single even number besides 2 to have at least 3 factors. For example, 4. The factors of 4 are 1, 2, 4. Okay, there's 3 factors, so it can't be prime. The next even number is 6. 1, 2, 3, 6. So there's 4 factors, so it can't be prime. Okay, so prime numbers are those numbers that only have exactly 2 factors. Now, the number 1 is not prime because it only has 1 factor. Okay, number 1 is not prime, and it's not going to be composite. It's just 1. It doesn't really have a classification as far as prime and composite goes. All right, so let's think about composite numbers. Okay, composite numbers are those numbers that have more than 2 factors. Okay, they're those numbers that have more than 2 factors. Okay, and now, obviously, with prime numbers and composite numbers both, they're unlimited in the amount that there is. They're infinite. Okay, you can always come up with another prime number. Now, obviously, it gets harder as the larger the number gets. Okay, the larger the number is going to get, the harder it's going to become to have figure out prime ones, just simply because of the math involved. Okay, so now let's make sure we understand factors. Okay, if we think about multiplication, you take a factor times a factor to get a product. Okay, I just want to review that because I want to make sure we're understanding what you should know what factors are before now. Okay, so if I say list the factors of 20. Okay, the factors of 20 are 1, 2, 4, 5, 10, 20. Huh? Yeah. Okay, 1, 2, 4, 5, 10, and 20. Those are all the factors. Those are the numbers that I can multiply together to get 20. Okay, I'll look at the factors of 24. Factors of 24 would be 1, 24, 2, 12, 3, 8, 4, 6, and that's it. Okay, now, if I said list the factors of 37. Okay, well, the factors of 37 are 1 and 37. So that number's prime. These numbers are composite. Once again, the reason they're composite is because they have more than two factors. Okay, so I want you to list on your own now. I want you to list the factors of 54. I would highly suggest listing them in their pairs. In other words, 1 and 54, it's like that, so you make sure you get all of them. Because I've found in the past that when you just start listing them out, like 1, 2, 3, you'll end up forgetting some that are toward the end. All right, that's what I'm saying. Do it that way, not just start at the first and start listing them. Three times 18. Reason I know it's, listen, hush and listen. Shut that door. The reason I know 3 is a factor is 5 plus 4, 54, 5 plus 4. You add the two digits together, and that's 9. 3 goes into 9, so 3 has to go into 54. Okay, that's the rule. That's the divisibility rule that we learned last year, that obviously some of you still don't understand or learn. What? When would you prefer me to call back on you? All right, now, when you're trying to list factors, for example, if we're listing the factors of 100, it is best to go through, in your mind, the rules for divisibility. So, as we already know, 1 and 100 are obviously factors. Okay, so I look at 2. 2 is an even number. 2 has to go into other even numbers. So 100 is even, so 2 goes into it. So I say 2 times what equals 100? That's 50. So that's the other factor with it. Then I go to 3. 1 plus 0 plus 0 is 1. 1 doesn't go into 3, so 3 will not go into 100. So then I move to 4. The rule for 4 is, if you look at the last two digits, if 4 goes into the last two digits, 4 goes into the whole number. Well, 4 does go into 00, okay? And so 4 goes into it 25 times, okay? Then I move to 5. Well, the rule for 5 is, if it ends in 0 or 5, 5 goes into it, okay? So 5 will go into it, and 5 will go into it 20 times. The rule for 6 is, does 2 and 3 go into it, then 6 goes into it. Well, in this number, 2 and 3 don't go into it, so 6 won't go into it. The rule for 7 is you just have to divide it out. Okay, you have to divide 7 into it and see if it works. Obviously, 7 is, 7, 14, 21, 28, 35, 42. That's counting by 7s, and so those are the numbers 7 go into. Not a rule for 8. When 9, if you add up the digits, 1 plus 0 is 1. 9 doesn't go into 1, so 9 won't go into it. And then we have the last one, which is 10. 10 goes into it because it ends in 0. You do not have to list 10 twice, because 10 times 10 is 100. Don't list it twice, only list it once. And so there's your factors. Now, obviously, I have the big gap in the middle, but, that way I can see the pairs as they're coming closer together. As you get closer together, like I can't have any number between 50 and 100 that's a factor, because there's no whole number between 1 and 2. Okay? When I get down here to 4, I have 3 in there, but I know 3 doesn't go into it, so there's no numbers between 25 and 50 that are a factor of 100. Okay? I have this one at 5. There's no number between 4 and 5, so that means there's no numbers between 20 and 25 that can be a factor of 100. Okay? That's the other reason I list them in pairs, is so I can see the pairs, and as I get the pairs, I eliminate numbers that are in between them. Okay, and that's why I use my rules for divisibility to do it, instead of just trying to start, and I know a lot of you, you randomly just start, well, I know 4 times that or 2 times that. That's fine, but you're going to end up leaving ones out more often than none. Okay, so without any talking, I want you to list the factors of 60. Okay, I want you to list the factors of 60. And I'm going to tell you there's quite a few of them. There's actually 12 of them. I don't want you to list all of them. Copeland, what's the first one? The first pair. Okay, obviously, we got 1 and we got 60. Okay, what's the next pair? Anthony. Yeah, 2's right. Not 24. Hush. 2 and what? 2 goes into 60 how many times? Two goes into 6 how many times? 2 goes into 0 how many times? Okay, so it's 30. All right, who's got my next ones? Nicole Cooper. You don't? Okay, Gracie? 3 and 20. That's right. Next one's Madison? Correct. 4 and 15. Next one, Gracie? 5 and 12. Right. Courtney?
I'm not Courtney.
Haley? Haley? Haley?
Go, Haley. Sorry. 10 and 12. What?
We're on.
No, sorry, 6.
Thank you.
Sorry, I was looking at the other one. Sorry.
6 and 10. Okay. Any others?
Yes, there's 12.
We've already got 12. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's all of your factors. Okay? So that's listing the factors. Okay, that's not all obviously we're going to talk about today. Next thing we're going to talk about is whether or not a number is prime or composite? Okay, whether a number is prime or composite. That's what we got next. Okay? This is fairly simple. All you have to do is tell whether it's got more than two factors or not. Okay? Courtney, Haley, excuse me. Do you have a question?
Yes. Whenever you do the primes and then you like do the 1 and then 50 is your, you know, can we do that line thing where you like put a line first and you put the prime and you like put 1 and 50, like 1 on this side and then 1 on this side?
For what?
Like this.
What is that?
Can I show you on the board, please?
Oh, like you do the factors? If you want to do the factors that way?
Yeah, like you put like 1.
Like, I mean, we did this. We did this where we went 160, 230, 310, 415, 512, or excuse me, 320, not 10. And then 610. Yeah, you can do that because you just go around it like that. Yeah, if that's easier for you, then yes, most definitely do that to list the factors. Now, whether a number is prime or composite is very simple. Okay, all even numbers are composite except for 2. So if you see an even number, then you just automatically put composite. Okay, now all odd numbers are not prime. Okay, some of the odd numbers are obviously prime because there's only one even number that's prime. But just because a number is odd, don't assume that it is prime. If we look at 23, well, I know that 3 times 7 is 21. Okay? I know you can get to 22, and I know you can get to 24. 8 times 3 is 24, 6 times 4 is 24, 2 times 12 is 24. Obviously, those are not prime numbers. 23 is prime because it's only 2 factors, or 1 in 23. Okay? So it is a prime number. So you just put prime. Now, if they ask you to explain why it's prime, then you would just say, because it only has 2 factors, 1 in 23. Okay, that's how you explain if it's prime. If it's composite, like 88. I could say 8 times 11 is 88, so therefore it can't be prime, it's got to be composite. That's how you would explain it. I am not requiring you to explain your reasoning. Okay? The directions say in the book, explain your reasoning, but you do not have to do that. All you have to do is tell me whether the number is prime or composite. Okay? Nicole? Huh? How do you know if it's prime or composite? You just have to I'll give you a good example. 51. Okay? 51 is odd. It is odd, so there's a chance that it's prime. Okay? But it's not. The reason I know it's not prime is because I know my rules for divisibility. The rules for divisibility say if I do this, 5 plus 1 is 6. 3 goes into 6. 3 goes into 6, so 3 has to go into 51. 3 goes into 51 17 times. And so therefore, it's composite. But if you don't know your rules for divisibility, and if you're not willing to go through those rules for divisibility, then you're not going to get them right. Bottom line. If you're just going to look at a number and go, that looks prime. Well, then you're going to be right about 50% of the time because it's either prime or composite. So, you can guess right, hopefully 50% of the time. Okay, but when you're dealing with odd numbers, for example, this is one that a lot of people miss as well. 87. Okay, that's composite. The reason being is because 8 plus 7 is 15. 3 goes into 15, so 3 will go into 87. Now, 3 goes into 15 5 times. That doesn't tell you how many times 3 goes into 87. That just tells you that 3 will go into 87. Okay, then you have to actually divide it out to see, how much it will go in there. And it's 3 times 29. Okay, and so that's composite. Nicole? No. First number has nothing to do with it. The second number? I mean, you can tell if the second number, are you saying the second number or the last number? Okay, because there'll be ones we'll have, I'll show you in a second. But no, it's not. I mean, the only way you can tell by the last number is if it's an even number. If it's an even number, then yeah, it's going to go into it. Another good one is what Gracie said, I think. If it ends in a 5, it can't be prime. Okay, that's another. So you eliminate the number 5, and you eliminate all even numbers. Okay, so if you think of it in these terms, and that's a good way to look at it. We have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so we've already said that if it's an even number, so I can cancel out those. We also know that if it ends in 5, that 5 goes into it, so it cancels out that one. Okay? So, 0 is because it's even. 0 is even. So you have 1, 3, 7, and 9. Those are the only numbers that the number can end in for it to be a prime number. Now, some of those still can be, we've already proven, now don't go, we've already proven twice that number and that number could also be, it doesn't, this should just give you an indication of, yes, it could be prime. Okay, so that's one way you can eliminate a lot of numbers, but there are exceptions to those as well. Okay, another exception to it would be 201. 201 is an exception to it. Because what is 2 plus 0 plus 1? 3. So 3 goes into it. So it's composite. Because 3 is going to go into that.
So composite is an even number?
Composite are even and odd. Just for example, 15 is odd, but 15 is a composite number. Right, 3 times 5 because it has more. I can go down the line. There's 15. Then the next one's going to be 21. Next one's going to be 25. Those are all composite that are odds. Okay, 27's composite. 29's prime. 31's prime. 33's composite. 35's composite. Okay, so realistically, and this is the way you need to look at it. For example, in the 30 numbers, 31, 33, 37, and 39. Those are the only 4 numbers from 30 to 39 that can be prime. Okay? 31, 33, 37, 39. Those are the only ones that can be prime. 33 can't be prime because 3 goes into it. 39 can't be prime because 3 goes into it. Okay, and so that's what you're left with. 31 and 37 are the only prime numbers between 30 and 39. I know, I have a watch on. It says 3:22.
Yeah, that's what it said.
Yeah. And she said 5 minutes early. Well, I know how to tell time. But, okay, but if the rest of those girls were jumping off the building, would you want us to follow? Then I'll show you where the ladder is. Be my guest. No, I don't want personal testimony time. All right. So tomorrow, we're not going to have any work over it today. Tomorrow, we're going to talk about the actual prime factorization. Okay? And that's talking about the factor tree and inverted division. Okay? That's what we'll discuss tomorrow and finish up the lesson. Okay? Volleyball girls, you can go.